Okay, boys and girls, welcome to our third video lesson in Chapter 10. Circles, 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 and more circles. Okay, our first theorem. In the same circle or incongruent circles, if two minor arcs are congruent, then their corresponding chords are congruent, and this theorem, because of the if and only if part, works both ways, so the converse is also true. We know this from what we did last section. So if these two arcs right here are congruent, they're both at 65, they're in the same circle, then the corresponding chords are also congruent. And if these two chords are congruent in the same circle, then their corresponding arcs are also congruent. If these two circles were congruent to each other, and these chords were equal, then these arcs would also be equal. Okay, and we know from last chapter, if these two chords are equal and their central angles are equal, then also we know that I'm sorry, I said that wrong. If the chords and or the arcs are congruent, then the central angles are also congruent. And same thing here on this side. If those two chords are congruent, then not only are the arcs congruent, but also the central angles are congruent as well. Two circles are shown. They're congruent. And Wx is congruent to Yz, so Wx is congruent to Yz. If those two arcs are congruent, then their corresponding chords are congruent. So if that's the case, and Wx is 7x minus 2, therefore Yz is 5x plus 6, those are equal. I'm going to do some simple algebra. I'm going to subtract the 5x from both sides. I'm going to add 2 to both sides. It looks like I'm going to get 2x is equal to 8. Therefore, divide by 2. X equals quattro, which now my answer is find the length of Wx. Well, Wx was this. 7 times 4 is 28. 28 minus 2 is 26, and that's the answer I'm looking for. Alright folks, our next theorem says if a radius is perp to a chord, or chord if you prefer, chord. If a radius is perp to a chord, then it bisects the chord. And again, we see the if and only if part right here, which means this works both ways. So, if a radius is perp to a chord, then it bisects the chord. Or if we go the other way, if a radius bisects a chord, then it is perp to that chord. So whenever we see a picture where a radius bisects a chord or a radius is perp to a chord, we know that the reverse is also true. So the next thing, a definition, a chord's distance to its center is measured by a segment that's perp to the chord. So if I take this chord right here, and I want to know how far it is from the center of my circle, I'm going to draw a segment from the center to the chord that's perp to the chord. And once I've done that now, I also know that then if I draw a perp, that those two things are equal. So x, this distance right here, is my distance from the chord to the center of the circle. If two chords are equidistant from the center of a circle, then they are congruent. That's our next theorem. This theorem also goes both ways. If two chords of a circle are congruent, then they are equidistant. So again, all these theorems work both ways. The theorem and its converse is also true. So if we say that PQ, let me get my pointer, if OP is congruent to OQ, then these chords are congruent. They're the same distance away. Or if I say AB is congruent to CD, that means now that OP is congruent to OQ, where the chords are the same distance away from the center. And that's what equidistant means. Okay, let's do some problems. Find the length of CD in the circles below. with center P. It says here that the two chords are the same distance away from the center. We get that from our picture right here. So that means now that AB must be congruent to CD. Also, because we're drawing from the center to the chord perpendicular, I now know that this is congruent to this. I also know that this is congruent to this. And in fact, all those halves are equal because the two chords are the same distance away, which means they are the same length. And our division prop says half of the same thing is the halves of the same things are equal. So I now know that AB, which is 8x minus 22, so I'll write that in purple, is equal to twice CD, or CE, it's twice CE, because CE is half of CD, so it's equal to 2 times x plus 1. Now let's just find x. So I have 8x minus 22 is equal to 2x plus 2. When I distribute, I'm going to minus the 2x. I'm going to add the 22. So it looks like I get 6x is equal to, well, that should be a 22, sorry, is equal to 24. Divide by 6, x is 4. Now let's answer the question. Find the length of CD. Well, CD is going to be the same length as AB. So CD is equal to 8 times 4 minus 22. 8 times 4 is 32 minus 22 is 10. Okay, let's do another problem. Woo-wee! Find the length of CD in the circles below at center P. Again, we see this two chords are the same distance away from P, so those two chords must be congruent. Okay, we know that the halves are all equal from the same logic as last time, because those two chords are equal, and they're both cut in half by anything that's drawn from the center to the chord perpendicular, so those halves are all equal. The radius of the circle is 26, and PE is 10. So this length right here in green is 10. And we're looking for CD, so we're looking for CD right here. Okay? The extra piece that they tell us here is the radius is 26, but I don't see any radii drawn. So I'm going to draw one, and I'm going to draw it very carefully, because I want to draw the right radius, and I'm going to draw it from the center to C. Once I do that, do we see now that I have a right triangle right here? If this was 10, this is also 10. Okay, so I'm going to just take this triangle and flip it over and redraw it right here. So here's my right angle. This is point C. This is point P. This was my radius that I drew. That's 26. And this was like the center, this is where the right angle is. Let's call that F. So this is point F, and that's also 10. Well, I'm looking at a right triangle that has a leg of 10, a hypotenuse of 26. Well, that's 5, 12, 13 times 2. So FC here must be 24. So I now know that FC is 24, which means FD would also be 24, or CD is double 24. So CD is equal to 48. Whoop, let's keep going now. Ain't this fun? In circle P, P is the midpoint of AB, which means now that's our center point right there. Let me put that in. That's our center point. And these two are congruent because P is the midpoint of AB. Now that means that those two chords are equal because they are the same distance away. So these two chords right here are equal. And if CR is 3x squared minus 1 and ST equals 11x plus 3, I now know that 3x squared minus 1 is equal to 11x plus 3. Okay, this is a quadratic equation. I recognize that from the x squared, so we're going to factor. I'm going to subtract 11x from both sides and the 3. So I'm going to get 3x squared minus 11x minus 4 is equal to 0. To factor this, I list out the factor pairs of the x squared term, 1 and 3. I list out the factor pairs of 4, 1 and 4, and 2 and 2. I'm going to play with my factors till I come up a grouping that gives me a difference of 11. Well, I see I'm going to get 1x and 3x. And I'm actually going to use the 4 and the 1 right here, because 4 times 3 is 12, and 1 times 1 is 1. 12 minus 1 is 11. So now it looks like, because I want 11, this is going to be a minus, and this is going to be a plus. X is equal to 4, or negative 1/3. Well, if x is negative 1/3, I don't think that's going to work right here. So x must equal 4. So the length of CR is actually equal to both, and it would probably be easier to go to here. X is 4, so CR is going to equal 11 times 4, which is 44, plus 3, which is 47. All right. Find the radius of OP. Given BP and PY are both 5. So BP and PY are both 5. I'm going to write those in. 5 and 5. Those two segments are equal. And I think we probably need to assume that these are right angles. That should have been given. AC is 7x minus 4, and XY is 2x plus 4. So AC is 7x minus 4, and XY is 2x plus 4. If those are right angles as I drew them in, now we know that AC is equal to 2 times XY. So I can write this now. 7x minus 4 is equal to 2 times 2x plus 4. Okay, that being said, we can find x. So let's do 7x minus 4 is equal to 4x plus 8. I'm going to subtract the 4x. I'm going to add the quattro. It looks like I get 3x is equal to 12, so x equals 4. Well, if x equals 4, xy would be 2 times 4 plus 4, which is 12. This was 5. We're looking for the radius. I'm going to draw that in here in red. Do we see this right triangle right now? This is 5. This is 12. This guy here must be 5, 12, ding, 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 13. Okay, find the length of a chord if it is 24 inches from the center of a circle with radius 26. So we're looking for the length of this chord right here. Okay, we know that this distance is 24. Good thing I can read. And it has a radius of 26, so we know that this length is 26, which we do know that, yes, this little distance right here is 2. But more importantly now, I'm going to redraw my radius, or draw a second radius right here. Okay, I now have a right triangle where this is 24, this is 26, and it looks like I have a 5, 12, 13 times 2. So this piece right here must be 10, which means if this is 10, this is also 10, which means now these two are 10 plus 10 our length of the chord is 20. Okay, here's one for you guys to do at home. And in fact, the first 8 people that send me an email with the correct answer, I'll give you a bonus point on our next test or quiz. I love this little incentive. If a chord is 15 inches from the center of a circle, so again, this would be 15 right here, and the chord is 24 inches, this has a total length of 24. And of course, if we are measuring a distance from the center, a chord to the center of a circle, this is going to be a right angle right here. Okay, what's the radius of the circle? That's the length we're looking for. Don't forget, we probably want to draw, hint, 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 another radius someplace else. Go ahead, solve that problem. First, what did I say? 8 people to send me an email with the correct answer. I'll give you a bonus point. Okay, a couple more just quick little words you're going to learn, and then we're going to wrap things up. Intersecting circles with a common chord. These two circles, they are not congruent. As we can see, they are different sizes. They are not concentric because they don't have the same center points. That would be A and B. Okay, but these two circles, they do intersect, and therefore, anytime two circles intersect, they have a common chord. That would be CD. It is a common chord, and the line of center, the distance between the two centers, is a line of center. Okay, certainly the line of center is always going to be perp to the common chord, and the common chord, of course, is also bisected, so this piece is congruent to this piece. We're going to use all this information in class to solve a problem such as this, just to whet your appetite. It's actually pretty cool and fun, and we'll do that in class tomorrow. So have a great day, folks, and we'll see you soon.